This endpoint is leaking some sensitive data. It took only a few minutes to find this. Let's make it more critical by retrieving some more sensitive data. In the previous videos, we have learned request smuggling, SSRF, XSS, and many more. So, from this video onwards, we will be doing hands on live bug bounty hunting on live targets. In this video, we will be targeting Tinder bug bounty program in HackerOne. Tinder is a dating app, so let's begin. Before we start hacking Tinder, we should go through all the program guidelines. Make sure you do not break any rules, or the company can take action against you. After reading all the guidelines, we can move on to the scope. Scope is where you can see the URLs and the wildcards you can hack on. Anything outside the scope is a red zone. Do not try to hack it, guys. Even if you spend time and hunt on out of scope target and get a bug, you still won't be eligible for a bounty. But there is an exception. If you look closely in the go.tinder.com is an asset belonging to branch.io, you can submit reports directly to the branch here, which means there is an option to submit the bug in an out of scope target. So make sure you read everything in the scope and program guidelines section. Before scanning the wildcards, we can start with the main site, tinder.com. So, our plan is to route all the traffic from this browser to our burp suite, and we will create an account and use this site as a normal user would and go through all the functionalities. First, we will look for IDORs and all the API endpoints for data leaks. In burp, let's add our scope. Open burp and select use advanced scope control. Then click add and then type in our target domain. This will filter out any other traffic from other websites. Now let's create an account and browse through our target website as a normal user. Tinder is a dating site, so we have option to like, dislike, chat, and also options to add our personal preferences. And we need a subscription to use some of the other features. After using it for almost 2 to 4 hours, we got a lot of request and response. Let's go through each and every one of them. These two endpoints caught my eye, api.gotinder.com and data.gotinder.com. This might be a possible target for finding any data leaks. In the logger section, I searched for our endpoint and then send it to repeater. This request was made to update the last activity time, and it identified the account using X authentication token. At this point, we can't find any data leaks at this endpoint. But when we move to the bottom section, the last activity date is updated with the data we give. So I thought, what if we give some random numbers? It gave me an internal server error. Then I removed the weights and just sent the number. Look at the response byte length. It changed to a huge number. So let's see what data it returned. We can see the name, date of birth, and some other sensitive data related to the person that matched with our account. But this shouldn't be this way. When we change the last activity date, it should show invalid activity date, but it returned sensitive data. Our next question is it enough for a bounty? Let's take our notepad. You should always have a notepad and write out your findings, the endpoints, and your objectives. From a bug bounty perspective, the most important thing companies care is their user data. So our objective is how to retrieve sensitive user data. The first information disclosure we found was at this endpoint and it's a post request. Endpoints that felt suspicious was API and data.gotinder. Then the exposed data was date of birth and type, which means selfie verified or not. But a date of birth is not that sensitive because anyone can give any date of birth. So we will look for some more critical data like phone number, email address, and chat of other people's if we can tamper with the authentication token in some ways. And also check if we can use features that need a subscription without a subscription. This is the edited version of my live stream in Twitch, so follow me on Twitch to never ever miss my live stream. The link is in the homepage link section. Let's go back to the video. The next feature that caught my eye is the matches page. It shows details about who liked our profile. But there's a catch. We need a subscription to see who liked it. So let's spin up the intercept and reload the page. So we get a traffic to api.gotinder.com, which we know leaked data from our old findings. So I sent it to repeater, then made the GET request. As I thought, the front end was blurring the images and the details, but still the API was fetching all the details. We got access to all the names, date of birth, image URLs, and a few other data without the need of a subscription. We are not going to report at this point, it's still not critical. So we will go deeper into this application. Let's write down our findings. Let's copy the endpoint we found the data leak. It was a GET request. The host is the same api.gotinder.com. The data exposed were the name, image, date of birth, and the feature was liked users. After a lot of attempts to retrieve the data, I just fed up and laid on the bed looking at the ceiling. Then something else came to my mind. The matching system of Tinder works in this way. If I like a page and they like us back, it's a match. So they hide the matches page to not let us match with the person without a golden subscription. So here we can see who liked us. So why don't we use that data to like them back and bypass the golden subscription to chat with them? That will be a critical bug. So let's see how the liking mechanism works. I intercepted all the traffic and sent it to repeater. There's a small error that happened during the intercept. That was my mistake. That's okay, we learn from mistakes. This GET request made to v2 slash fast matches is the request that shows us who liked our profile. And this request we first saw in the place of matches page request shows us the details of who we liked. So keep that in your note. We must see two more requests to get the full idea. This request is sent while we like a profile. So what if I change this ID to the ID of the person who liked our profile? Then we can like their profile using burp and then it will be a match. So we will bypass the golden subscription system. I will show you one more request. This is how you dislike a profile. So while you are hunting, before thinking about the complicated tools and the complicated methods, you should think of it from a hacker's perspective and from the company's perspective of what is critical for them. This is how you hunt manually, where automated tools can't do anything. This will distinguish you from the people using autonomous tools and will make sure you will get a proper skills and bounty. But this is a hard task, so most people won't do this. Even though this is a small video, it took me hours of walking around looking at the ceiling and finally think of it in this manner. If you want more of these kinds of video, comment below. Now let's go back to our target. I will show you one more request. This slash v2 slash records shows details about all the recommendations in our homepage. Let's note it down. This may help while we hunt more. One more thing you should check while hunting is the HackerOne activity page. Search your target and see if there are any disclosed reports. In the case of Tinder, there are no disclosed reports, but there are a lot of findings in the undisclosed section. So, in our burp, there is another issue. This v2 slash fast matches is only returning the UUID related to the user, but the ID we need is an ID like this. Then I thought, what if we can brute force this ID? Then I selected few of these IDs from my like section and gave it to ChatGPT and looked for similarities or patterns in these IDs. But still, it will be hard to find. So I started to intercept more traffic. In one of the requests, I found this parameter. Type is equal to recently active along with our fast match path. So this endpoint along with the ID revealed the name. So if we make changes to the parameter, it may reveal more and more details. One thing we know for sure is the endpoint api.gotinder.com holds all the data and the path is from v2. So let's go to the sitemap section. Here select the endpoint api.gotinder.com and click on the drop down. We can see all the v1, v2, v3 versions and all other paths. So let's select the v2 for now. We will go through each and every one of them later. Inside the v2 we can see the matches section. It has a parameter include conversation. When I give it true, it revealed all the chat details. Let's note down this path in our notes. It may help in the future. Now let's look for all the parameters related to the fast match. So what I'm trying to prove here is the only way to learn bug bounty is to choose a target and start hunting on them. That's the only way you are going to learn. You can't learn everything and start bug hunting. You will only learn it on the go. Make mistakes and learn from your mistakes. So now let's try to reverse engineer this API v2 path. If you don't know how to reverse engineer an API, I have a separate video on that in which I reverse engineer Instagram API. So go and watch it. Now let's reverse engineer this API/v2 path. For that, we need MITM web and MITM proxy to Swagger. The steps to install both of them are in the Instagram API reversing video. So go watch it. Now let's run the command mitm proxy to Swagger, then the flows file and our outputs file, then our API path. Run the command. Open any browser and search for Swagger editor. Now import our file. Now you can see all the requests, all the method and all the paths in a detailed manner. Click on any of the method to see a detailed request and response. Burp suite is enough, but this will help you to analyze it in a detailed way and see the request in an ordered manner. One more thing, in bug bounty, you will always get stuck at some point. You just need to persist and learn. Every target you choose has a bug. There is no program as completely secure. So make sure you check everything. I was about to show you some GraphQL based bugs, but then due to some aggressive scans, my account got blocked. No worries, we will move on to the wildcards now. There is a way for testing SSRF using wildcards. I am using Waymore to pull down every URLs from the wildcard. You can use Waymore or Sublister or any other tool to do that. Then we will be using Burpsuite Collaborator. If you don't have Professional Edition, then you can use other websites like Webhoops and many more. I have explained each and every one of the alternatives and the steps to do SSRF from using wildcards in this video. In the channel video section, search for SSRF and you will get the video. I have explained live examples, alternatives of Collaborator and each and every steps of hunting SSRF. It also includes some live testing on AT&T, LinkedIn, etc. I have also included false positive and each and every command to run. I will provide this video link in the description. In this case, I am using Burpsuite Collaborator. You can also use webhooks. This also works similar to Collaborator. Many of the alternatives and how to use are shown in the SSRF video. Go check it out. This is my blog on different cases to check for SSRF. This is provided in the description of the SSRF video. So with that, we can move on to our target. After running all the commands, if you get a DNS and HTTP lookback from the backend server, make sure the IP is from that server. Then we can start exploiting SSRF. You should also check if your target has an APK. If there is, we can pull down URLs from the APK file. This is done using a tool called APK leaks. Just search for APK leaks in the channel video section And you can find a detailed video on how to use APK leaks, APK tool, and a few more tools to test APK bug hunting. If you want a detailed video on APK bug hunting, how to route the traffic from an APK to our burp, then comment down below. I would share one more thing. Have you noticed the request sent from my burp? You can see the collaborator link everywhere and specific headers. This is automatically added by a burp extension called collaborator everywhere. Just open the extension section and search for collaborator everywhere. Download and install. There is one more thing I would like to test in Tinder. It is selfie verification. We can try to bypass it. By the way, Tinder is just taking a pic and uploading. No face liveliness, and I didn't see any reuse detection. When I took the photo from a screen, it showed glare error. So there is some defect with the identity verification. There might be a way to replace the image while the request is passing, or try to directly call the verification endpoint. We can also replay a previously successful verification, but to test all this, we may need to intercept the traffic from Tinder APK. If you want APK related bug hunting videos, comment below. So let's wind up this video. If you are interested in my content, like and subscribe. I make videos on bug bounty, reverse engineering, and low level programming.